The next is defects of vision and their correction. Actually, it is very difficult to understand. If you don't understand anything, you have to ask me your doubts. Okay? Actually, it take time. It take time to understand the defects of vision and their correction. The vision problem. Okay. For example, I am using glass because without glass I cannot see the far objects. Understood? So that it's a defect, eye defect. Or some people find it very difficult to read newspaper. Aged people, especially the aged people, find it very difficult to read the newspaper. What is the problem? They cannot see the nearby objects. They cannot see the nearby objects. But far objects, no problem. But for me, I cannot see the far objects. I can see the nearby objects. I mean, I can see the laptop, mobile, everything without the glass. But the far objects, it's very difficult for me. So these are the defects. There are certain defects of eye, and I will explain that reason of the defect, also the corrective measures. All of you please listen. It's very difficult to understand. You can ask me doubt. Okay, listen. There are three important defects in our syllabus. There are many other defects, but in our syllabus, there are three defects. One is myopia or nearsightedness or short sight. Nearsightedness is also said to be short sight. I have a myopia. I have a short sight. Short sight means the nearby object I can see. That's the meaning. Short sight means the nearby object I can see. Far objects I cannot see. So one eye defect is myopia. The another name also you have to understand, nearsightedness. Nearby objects we can see. Other objects we cannot see. Hypermetropia, it is far-sightedness. The distant objects we can see, but newspaper etc. we cannot see. Nearby objects we cannot see. Far objects I can see. We can see. Okay, that problem is hypermetropia, far-sightedness. The far objects only we can see. Understood? Nearsightedness means only near object only we can see. Nearby objects only we can see. The another age-related problem is presbyopia. I will discuss it separately. Don't worry about that. So all of you please write down all these defects. The defect of vision. There are three types of defects of vision. Please write it. I will explain each and everything in detail. I will explain everything in detail. For the time being, you please write these three defects. If you have written, please raise your hand. If you have written, please raise your hand. Nishita, Joshida, Samruddhi completed. Lina, do you have any doubt? Everyone is okay, understood. So this diagram I will discuss. Okay, don't worry about this diagram. Most of the students find it very difficult to understand this diagram. Don't worry, but I will take time. Okay, in order to explain this diagram, I will take time. So I will explain. I am going to explain the first eye defect, which is myopia. Myopia or nearsightedness. Only nearby objects I can see. Only nearby objects I can see. This defect may arise due to the reason you have to learn. What is the reason for myopia? Only nearby object I can see. Okay. What is the reason? Excessive curvature of the eye lens. Excessive curvature means you know that the eye, the structure of the eye look like this. Understood? This is the structure, eyeball. This curved one is cornea, right? This curved one is cornea, and below this cornea there is eye lens. It is convex lens, we know that. This is the eyeball. Okay, our eye look like a board like this. This membrane is retina. Understood? In the back side there is a membrane which is said to be retina. The image should fall on the retina. Wherever we keep the object, the image should fall on the retina. Then only I can see. If the image does not fall on retina, we cannot see it. So I will explain. Let me explain thing. After that, you can ask me doubt. Okay. So myopia. The reason, you please remember, the excessive curvature means this length of the eyeball is too large. Curvature means this excessive curvature. Eye lens. Okay. Eye lens. Our lens is like this, adjustable. Our eye lens look like this. But sometimes, I mean, for some people, the eye lens look like this, excessive curvature. Okay, this is said to be excessive curvature. For healthy eye, the lens should be look like this. Just for your understanding, I am telling you. The medium range, the curvature, the width should be medium. If the width is too large, it is excessive curvature. I mean, width is too large. Understood? So if we have a eye lens look like this, we have a myopia then. Only nearby objects we can see properly. The far objects very difficult to see. The lens, I am talking about lens. Okay, lens curvature is too large. It is short sight. And elongation of eyeball. Eyeball means the width. Sometimes the width. This is said to be width of the eyeball. Understood? This distance. This distance is. Can you see that? This distance is the width of the eyeball. If this width is too large, if the eyeball distance or elongation, this distance we can say it as elongation. If the elongation of the eyeball is too large, then we will have a myopia. Myopia means the nearby objects we can see properly. Okay, only nearby objects we can see. So for the time being, don't draw this diagram. I will definitely explain the diagram. Don't worry about that. You please write this heading and write the reason. Okay, please write the heading and write the reason. If you have written this thing, you please raise your hand. If you are 100% clear whatever I have explained, if you have understood and finished writing, raise your hand. If you don't understand anything, please ask me. Lina, Nishita, Joshida, Samruddhi, everyone is clear. And this, remember, this diagram is very, very important. You must draw the same diagram given in textbook. Actually, in my opinion, only one diagram is sufficient. First and third is sufficient in my opinion. But you must draw all the three diagrams. Then only you will get full mark. Okay. Myopia. If in exam, if they explain myopia, you must write the reason and also this diagram you must draw. If you write the reason and this diagram is drawn, you will get full mark. Okay. Then let me explain this diagram. All of you please listen. Let me explain this diagram. If you don't understand anything, you can ask me. What is the far point of healthy eye? Please tell me. What is the far point of healthy eye? Far point? Infinity. Healthy eye. I am talking about healthy eye. If my eye is healthy, remember, I have some eye defect. If my eye is healthy, I can see the star. You agree with me? If my eye is healthy, I can see star. If I remove my glass and watch the star, I cannot see the star. I am saying the truth. If I remove the glass and watch the star, I cannot see it. So the healthy eye has a far point infinity. Far point means the object, the maximum distance between the object and our eye is far point. For healthy eye, the far point should be at infinity. Okay, so but for if the person has the myopia or nearsight, the distance should not be beyond certain level. The distance should not be beyond certain level. For example, O is the object. Let me give some example. The far point may be around a few meters. Let me write some number for your better understanding. Let me write some number. Is that okay? Let it be, say, 50 meter. Understood? If the person, just an example I am writing, if the person has a nearsightedness, he can see those objects which is either 50 meter or below 50 meter. If the object is placed more than 50 meter, he cannot see properly. So the far point is theoretically infinity, but if the person has myopia, his far point is not at infinity, it will be some distance. So for example, 50 meter, 100 meter, like that. Is that okay? If the person has myopia, his far point is not infinity, it will be some definite distance. For example, 150, like that. Is that okay? You agree with me? You agree with me? Nishita, Joshida, everyone is clear? Samriddhi, Lina?
Yes, sir.
Okay.
Yes, sir.
So, for example, there is a letter. There is a letter O. Let it be O. Okay, there is a letter O which is 50 meter away from me. I can see it. I can see it. Why? Because the rays coming out of O, the rays coming from O enter into my eye. The rays, there is a letter O or some letter, some object. So for example, some object is there. The rays coming out of the object will enter into my eye, and if it is passing through the eye lens, it will bend like this. If it passing through the eye lens, it will converge, and ultimately I will be getting some image here. If the image is available on the retina, I can see it. But if the object is above O, greater than O, the image I will not be available on the retina. That reason, that part I am going to discuss in the second diagram. Okay. The first diagram is simply about the far point. Far point will be some, for example, 50 meter, 100 meter, like that. If the object is kept beyond 50 meter, this eye will not reach the retina. It will reach a small distance in front of the retina. The image will fall before retina. Before retina. I will explain in the next diagram. Okay. So, O I can see. O I can see. I told you, if the object is 50 meter, if the object is say around 50 meter, example, okay, I can see that because the image of O will be available here. The image of O will be available here. This is the object I kept. The corresponding image definitely will fall into my retina. I have explained in the first diagram already. I have already explained in the first diagram. If the object is 50 meter away, from the first diagram it is clear. Definitely the corresponding image will definitely fall on the retina. But the problem is, if the object is placed above 50 meter, for example 70 meter or 80 meter, something like that, or at infinity, you know that for example, let me say it is infinity. If the object is placed at infinity, the rays coming from O dash, this same object is placed at infinity, the light rays from object will be parallel to the eye lens. If the object is very very far away, the light will be coming like this, parallel to the eye. After converging, we get the image at this point. The image is obtained in front of the retina at 50 meter or below 50 meter. If the object is 50 meter or below 50 meter, the image will be made available in the retina. But if the object is some distance away from 50 meter, say for example at infinity, if the object is placed at infinity, you know that the light will be coming like parallel rays. After entering the lens, it will converge. If the eye lens is too thick, the converging will be much larger. I told you already, if the eye lens is too thick, excessive curvature, the converging power will be too large. So it will bend sharply. The eye lens will bend it sharply because the curvature is strong. If the more curvature of the lens means the light will bend strongly. The light will bend strongly if the curvature of the width of the lens is too large. So for a myopic eye, the lens has much larger thickness. So the more converging take place, more converging of the light take place, the O dash. If the object is at O dash, the corresponding image I dash will not fall on the retina. If the object is placed say away from 50 meter, the corresponding image I dash will not reach the retina. So since the image does not reach the retina, the O dash object I cannot see properly. The I dash should be made available on the retina, then only I can see O dash. So is that okay? Clear?
Yes, sir.
Okay. So I will repeat, don't worry. All of you please listen. So that is the reason, okay? The excessive thickness is the main reason. So the bending is too large. Bending of the light is too large. I dash does not fall on retina. How can we correct it then? How can I see on O dash? How can I make I dash fall on retina? I dash must fall on retina, then only I can see the O dash. How can I make it? How can I make that adjustment? I will tell you. 1 minute, just 1 minute. Just one. All of you please listen. Okay, all of you please listen here. So if the object is O, okay, what I am saying is, listen. I am putting a concave lens. What kind of lens is this? This is said to be concave lens. What is the nature of concave lens? What is the nature of concave lens? The nature of concave lens is it will diverge the light. This is the concave lens. The property of the concave lens is it will diverge. If the light is coming like this, it will not go like this. It is opposite to that. It will diverge. We have already studied property. If the parallel rays coming, it will diverge. It will diverge. That diverging should be done before the light enter into my eye lens. The diverging, a small diverging is required before the light fall on my eye, because there is a thickness is too large. The eye lens thickness is too large. So small diverging is required before the light enter into the eye lens. So it will converge, but it will ultimately reach the retina. Why? Because before this sharp converging, a little bit of diverging is already done with the help of concave lens. With the help of concave lens, a little bit of diverging is already done. So even if the converging is too sharp, the image will reach retina. Understood? So I hope you have understood. My eye lens is converging is too large. So before reaching the eye lens, a small diverging is done. Small diverging followed by converging. Ultimately, the image will enter the retina. So that is the object. So if the object is at infinity, the light rays coming like this. If the object is at infinity, O dash is at infinity, the parallel rays is coming like this. To small extent it is diverged with the help of a concave lens. Small extent, small angle it is diverged. Then the sharp converging take place, but since there is a initial diverging is done, the ultimately I dash, O dash is somewhere here, okay? O dash is somewhere here at infinity. I dash will be available on retina. eye dash will fall on the retina. I can see the star. I can see the star. And the if the object is less than infinity, I can see then because of the accommodation. I mean the eye lens width will be adjusted. I have already explained. The eye lens width will be automatically adjusted if the object is not at infinity. But the main issue is this O dash. I cannot see O dash. So in order to see O dash, a small diverging lens is placed. So I can see O dash. And for other objects, for if the object is not at O dash, I can see because the eye lens width is automatically adjusted with the help of ciliary muscles. The ciliary muscles help our eye lens to adjust the width. So other objects will be with the help of accommodation. I can see O also. Okay, with the help of accommodation. So O dash I can see. So other objects I can see with the help of accommodation. So I hope you have understood. All of you please draw this diagram. Look at the diagram again. If you don't understand anything, you please ask. Please draw this diagram neatly. The highlighting is not required. I just highlighted to make you understand. Okay.
Sir, mine's done. Can I leave?
Tell me what happens. 1 minute. Parallelly, there is another meeting. In that meeting, a test is conducted. All of you, if you have drawn this diagram.
Sir.
1 minute. 1 minute. Lyle. Sorry. Lyle. What happens? Lyle has, okay. You are writing the exam, right? Everyone is writing the exam.